I'm here in the chemistry physics building in the large lecture room. It's completely empty, but I wanted to come here to solve a problem, example problem, about deriving dimensions of physical quantities. And we're going to figure out the dimensions of force. And we're going to figure out the dimensions of force using the equation that defines force. You probably know this equation. It's force equals mass times acceleration, or F equals ma. So we're going to use that equation to figure out the dimensions of force. And we're going to use what we've learned about dimensions. So we've learned about some fundamental dimensions of space and time and mass. We've learned about some derived dimensions of familiar quantities like velocity and acceleration. So let me first just, on the whiteboard, remind us of those dimensions, of the fundamental dimensions and dimensions like velocity and acceleration. So space has dimensions of length. We denote that uppercase L. Time is a fundamental dimension. We denote that uppercase T. Mass is a fundamental dimension. We denote that uppercase M. And then we talked about velocity. Tells us how fast or slow we're going. Its dimensions are length divided by time. And acceleration tells us how we're speeding up or slowing down. Its dimensions are length divided by time squared. And we're going to use that working knowledge and this famous equation, F equals ma, force equals mass times acceleration, to figure out the dimensions of force. Now, the important thing about all physics equations, little physics equations, big complicated physics equations, is that the dimensions of the left-hand side, dimensions of the right-hand side, must be the same. So, in this example, the dimensions of force must be the product of the dimension of mass times acceleration. And we know the dimensions of mass and acceleration. That's on the right-hand side. That means we can figure out the dimensions of force that's on the left-hand side. So dimensions of mass, uppercase M. Dimensions of acceleration, length divided by time squared. The product of those dimensions then is mass times length divided by time squared, and that's the dimensions of force. And so we've used a dimensional analysis, applied it to the definition of force, applied it to F equals ma to figure out the dimensions of force from the dimensions of acceleration and mass. You could do the same thing, use the same technique if you wanted to know the dimensions of energy, for example. That's another important physical quantity.